Welcome back. Today we're going to be evaluating limits using a graphical approach. The way that you evaluate limits using a graphical approach is you look at the value that it's approaching. So in this case, all of these different graphs are all approaching 2. You look from the left-hand side of the graph and the right-hand side of the graph to see where that value is approaching, what y value it's approaching. So here, for all 3 of these graphs, we have the limit of f of x, where each of these are different functions, as x approaches 2. So for each of these, we're going to be looking at the left-hand side and the right-hand side of what is happening to the graph at 2. So if we look at the first one, for example, approaching in from the left-hand side means looking at the x values that are less than 2. Those would be to the left of 2, like 1 and -1 and -2, but coming in closer and closer to the value of 2. So if we come over here and we're getting closer and closer and closer to the value of 2, we're approaching 2. It looks like it's approaching this y value of 1, 2, 3, 4. So from the left-hand side, it's approaching a y value of 4. Then you look at what's happening to the right of it, so numbers bigger than that, like 3 and 4. When you come in from the right, as you approach 2, as you get closer and closer, it's also approaching 4. So in this case, the limit as x approaches 2 for f of x, the limit would equal 4 because it's approaching 4 from both the left and right-hand side. Now this one, as we're coming in from the left, getting closer and closer to the value of 2, in this case, it's approaching the y value of -1 because it's just a horizontal line at -1. But when we're coming in from the right, so all the numbers bigger than 2, the closer and closer you get to 2, all of these values are approaching +1. So if they're approaching different values from the left-hand side and the right-hand side, then the limit does not exist. Anyone seen Mean Girls? The limit does not exist. That was a good movie. Okay, so then the last one we have here, as we're coming in from the left-hand side, this value is going up, 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 which means that it's approaching positive infinity. And then if we look from the right-hand side, it's also going up to infinity, which means that the limit as x approaches 2 for this graph here is equal to positive infinity. Now, let's look at some examples to make sure that we understand evaluating limits using the graphical approach. Here it says, find the limit for g of x, so this blue function here is g of x, as x approaches -1. So we come over here at -1, and we look to see what is happening to the left. So as I get closer and closer to the x value of -1, you see the y value that it's approaching is right here, like it's getting closer and closer to that value of 3. And then from the right-hand side, it's also approaching that value of 3. So in this case, the limit equals 3. Now, you might be thinking, wait a minute, but right here, there's a solid line, and that's at 4. Well, yeah, that's what g of -1 equals. So if I asked you, what does g of -1 evaluate to? Then yeah, you would tell me that the answer is 4. But ultimately, this entire graph is not approaching 4. It's approaching 3. It just so happens that exactly at -1, it equals 4. Hope that makes sense. So for example, here, we're going to find the limit and we're going to evaluate at 2. So this one is asking what is the limit as x approaches 2 for this function h of x. So if we come here at 2, coming in from the left-hand side, it looks like the y value it's approaching is -1. And coming in from the right-hand side, the y value it's approaching is also -1. Limits do not mean it has to equal that value. It means what is it approaching? It's getting closer and closer and closer to the value of -1. However, in this case, h of 2, I'm asking, what does h of 2 actually equal? Well, at 2, there's an open circle, which means it doesn't equal anything there. So unlike the limit approaches -1, but evaluating, it does not exist. All right, so one-sided and two-sided limits. Basically what we were just looking at were called two-sided limits. because there was no plus sign, there was no minus sign, which indicated that we need to look at the graph from both the left-hand side and the right-hand side. And just like in one of our examples, how it didn't approach the same number, the limit did not exist. Both one-sided limits, meaning from the left and from the right, have to approach the same number to exist. So that's essentially what we just did. Now we're going to look at it just from the left or just from the right or from both. So the way that you know if we're asking, is the limit approaching from the left, is you'll have some number, x approaches some number with a negative sign to the right of it. That indicates that we want to know, what does the limit approach from the left-hand side of the function. If it has a positive symbol, then we want to know what is the value approaching from the right-hand side of the function. So for example, here we're going to evaluate a ton of these from the left, from the right, from both sides. So for example, this first one here says, what does the limit for f of x approach? X approaches -2 from the right-hand side. So coming in from the right-hand side, meaning all the numbers bigger than 2. So first of all, let's identify where is -2. And all the numbers coming in from the right. So all the numbers bigger, like 2 and 8 and 6 and 4 and 2 and 0 and -1. All of those numbers were bigger than -2. And we want to know, as we get closer and closer to -2, what does the y value actually approach to? And it looks like here, from the right, it's approaching closer and closer and closer to the value of 7. So coming in from the right, the limit would approach 7. But then this piece, part B, says that x approaches -2 with a negative symbol. That indicates coming in from the left. So if it's coming in from the left, then we need to look at numbers smaller than -2, and we get closer and closer to -2. So if we start here and we get closer and closer and closer to -2, from the left-hand side, it looks like it's approaching +6 instead. So coming in from the left and from the right, they did not approach the same number. From the right, it approached 7. From the left, it approached 6. So the two-sided limit, meaning there is no symbol next to it, as x approaches -2, because they are approaching two different values, that means the two-sided limit does not exist. Okay. Now, if we look at +2, part D says, what is x equal at +2? So D says 2 coming in from the left, so all the numbers less than 2. As we're coming in from the left, at 2, it looks like the y value it's approaching is 6. And then part E says 2 coming in from the right, so all the numbers bigger than 2 coming in from the right. It looks like it's also approaching 6, which means that the two-sided limit for x approaches 2 would be 6, due to the fact that it's approaching the same number from the left and from the right-hand side. And then finally, evaluating. So all of these were limits, but when it just says f of -2, we want to know, what did it actually equal at -2? So if we come over here, let's see, at -2, if we come up here, it was an open circle here, but it was a closed circle here, which means that at -2, it evaluates to +7. All right, so for our next example, it says, what is the limit as x approaches 0 from the right? So the number is bigger than 0. Remember, 0 is right here. So coming in from the right, when we're getting closer and closer to 0, it looks like the y value that it's approaching, not necessarily equal to, but approaching, is +1. Coming in from the left-hand side of 0, so all the numbers less than 0, it looks like the y value that it's approaching is right here, and that's at -3. So remember, two-sided limits only exist if they approach the same number from the left and from the right. So since this approaches 1 and -3, that means that the two-sided limit would not exist. But then when we actually evaluate, what does f of 0 equal? Remember, that just means we look at 0 to see where is it actually evaluating to. Both of these have an open circle, though, which means even though the limits approached a value of 1 and -3, because they're not solid, that means that it was an open circle, so it did not exist, which means you could say that f of 0 is either D&E for does not exist, or you could say undefined or something like that. All right, so let's look at this multiple choice question that I got off Khan Academy. It says, which graphs agree with this statement? Limit as x approaches -1 from the left-hand side. Remember that negative symbol there means from the left-hand side. And we're trying to figure out which one actually approaches 2 from the left-hand side. So we're only looking at numbers from the left-hand side, looking at -1. So -1, -1, and -1. So coming in from the left-hand side, so the number's lower, it looks like this one is approaching 2. Coming in from the left-hand side of this one, looks like that one's also approaching +2 at -1. And then this one, though, coming in from the left-hand side, it's approaching -1, the y value of -1. See here, coming in from the left, it's down here, which is at -1. So even though it looks like it's approaching the value of 2, that would be coming in from the right-hand side for C. So we would not include C in this answer because that's what it approaches, coming in from the right, not from the left. All right, so sometimes we're trying to find the limits of piecewise functions, which means you kind of have to be able to graph the piecewise function. In order to graph piecewise functions, what I do is I look to see where it's starting, and then I look to see where it's going. So I just create a little chart. So like for the first one, I plug in +3. If I plug in 3, 3 plus 1 is at 4. So that means that it's going to start at +3 and 4. And then I look to see where it's going. It says less than 3, which means that it needs to be all the numbers to the left of 3. Since it has a slope of 1, remember rise over run means that you either go up 1 to the right 1, but those would be numbers bigger than 3. So instead I would go down 1 to the left 1, down 1 to the left 1, down 1 to the left 1, so that it has a slope of 1, but it's going in the left direction because it says that the domain is x is less than 3. So then if I do the next piece, this one starts at 3, but it's not including. So if I plug in 3 squared minus 5, you know that's 9 minus 5, which is 4. So here I would still start at 3 over 4, but it was an open circle. However, it's already closed from the previous one. And then you can plug in 4 if you want to and say, you know, that's 4 squared minus 5 to get the next number. So then that would be what? 16 minus 5, which is 11. So then you could be like 4 at 4. It goes up to 11. Yeah, so 11's like up here. And then, you know, it kind of creates a parabola. But let's kind of just sketch it instead so that we can actually see a parabolic shape. So that we get the idea that that is indeed a parabola. Okay, so now that we have the shape, if we evaluate, it says, what is the limit as x approaches 3 from the right-hand side? So coming in from the right-hand side, all the numbers bigger than that. It looks like in this case it approaches 4. And then this is x approaches 3 from the left-hand side. So all the numbers less than coming in from the left-hand side. is also approaching 4. And so since it's approaching the same number, that means the limit as x approaches 3 is 4.